Hi guys and gals, and welcome to Magic. This is one of those peculiar things that doesn't even have a name because it's not even in theory possible to do with any other software development programming platform on the planet besides Hyperlambda. So I'm not really sure what to call it, but it's actually extremely useful. You see, so first, let's go to Tools, let's open up HyperID, and let's expand Modules, and let's find our FAQ folder, and let's click these three dots, choose Active Folder, choose New File, and write, for instance, aggregate integrations.post.hl. So we now have a post HTTP endpoint. Let's provide some arguments and declare these as, for instance, name, string, name, email. Then let's do some basic validation, email, validate, thank you. Validators, email, app.arguments / email. And then let's do some validator for name too, just to be nice. And then name and min, 5 characters, max, I don't know, 25 characters. So we now have some basic validation on our input arguments. Now what we want to do, we want to integrate with an infinite number of HTTP web APIs. Now, the way we're doing this is that we're expanding upon our code database. If you saw the Hyperlambda course, then in, I think it was in the second video, we created this database. The database is called code. It has one table called snippets, with an auto increment snippet underscore ID, which is an integer, which is the primary key, and then it's got content text. Now that's it. There's a link in the description of this YouTube video to that video if you didn't watch it previously. This one will walk you through how to actually create this database. Now what we're going to be doing here is that we are going to connect to that database. Code is its name. Then we are going to do data.read. Table, snippets, values, columns, content. Now, if we just now execute this thing, then we're basically reading, and actually we can prove it, lambda to hyper, :x, dot, / and then log.info, :x, -, we can save this thing and we can invoke the endpoint and pass in name, Thomas, email, th@aista.com, and then we can execute this endpoint. We can close this guy, guru meditation, darn it, let's see why, copy, management, misc, log. I don't know how to handle the email argument. We did a bug here in our code. Yeah, not gateway, sorry, aggregate integrations. Sometimes it goes a little bit fast even for me here too. Let's try again. So now we invoke the endpoint. So now if we check out our log, we should be able to see the results. As you can see here, it perfectly invokes our data.read connection, but we don't have any records. That's because before I started this YouTube video, I went here, I chose the code database, and I did delete from snippets. And you should too, in fact, such that you don't have any of your old snippets from the Hyperlambda course. Now, if I do select all from snippets, there's nothing in my database, and that's the purpose. So now we want to open up management. We actually misc. We want to go to the evaluator. Then we want to create a bunch of Lambda objects. Lambda. And then the first one can, for instance, I don't know, http.gets, https / aista.com. And that's basically what it does. Okay, it gets the aista.com. Then we want to transform it. Actually, we don't want to transform it yet because we want to have a result node. Then let's call this one aista here. Then when we have invoked the get endpoint, we want to actually aista status. Then we want to set its value, colon x colon at dot result slash asterisk slash ista dash status to get value. Actually, we can do it like this. We don't need to even retrieve its value. Now, of course, if we execute this, you see here, we don't get anything because we need to eval it. We eval it now, you will see that it actually retrieves and then it sets the status code of ISTA here, right? So that's kind of like the purpose. Now we want to do data.connect, connect to your code database, and then we want to do data.create table snippets and values content colon x colon at, and we need a lambda to hyper here minus slash asterisk content the value of this guy. So now if we execute this guy, then what you will see is that we are basically inserting a new Hyperlambda snippet into our code database. If we do select all from snippets, we need to change the database to code, execute the SQL, you will see we now have Hyperlambda in this database, right? Let's continue and create a couple of other ones too. Let's create, for instance, one that, I don't know, you know what? Let me find something. HTTP get. I guess we can do this one. Dot lambda. And then let's do lambda to JSON, colon x colon, minus slash asterisk slash content slash all. Then let's do dot result, JSON placeholder. Now we have transformed the result to JSON. Now we want to actually set the value at dot result slash asterisk to the result of this, implying we basically end up with JSON. Let's eval this just to verify it's working. Lambda. And JSON placeholder, why didn't that work? Because we are doing lambda to JSON x at http.get. So let's try again. So now you see we have JSON here in the JSON placeholder. Now we want to insert this one too. Okay, data.connect code data.create table snippets values content colon x colon, and then we want to do lambda to hyper colon x colon at dot lambda slash asterisk. Then we want to insert the result here. We now check out SQL Studio again, and we do another select here from our code database. Select all from snippets. You will see now we have two records. One of them is invoking the JSON placeholder blah blah. The other one is invoking ista.com. And we can continue doing this exactly as we see fit and invoke as many HTTP endpoints as we want to. Including, for instance, Supabase and Hasura. We can have thousands of these. And just to demonstrate an idea here, I want to sleep for 5,000 seconds here, right? And then I want to do sleep 1, and then I want to do set dash value colon x colon at dot result slash asterisk finished. Okay. Then I want to do sleep 2. I can try to write finished correctly. Now we have a whole bunch of snippets. Agree? Right? And I mean, we could have thousands of these if we wanted to. We could have an infinite amount in theory. What we want to do with our Hyper IDE HTTP endpoint now inside of our fact thing, where we are aggregating all the integrations, is that we want to now do a for each :x: at data.read character turn tab, and then we want to have a lambda object here at the top, dot lambda, and for each record we want to add into our dot lambda object here now, and we want to add a fork. Actually, we want to add it inside of a wait. So now we are reading all snippets from our code database, and we are iterating through each content column that is returned by that read invocation. Then we are adding into lambda.wait here a fork statement. Then we want to transform the currently iterated content from hyper to lambda :x: at .dp/hash. And then we want to add that part into the next add /*/*. So what's happening here now? Okay, so first we're doing the validator part. So I presume you already understand that. Then we have a lambda, not wait, join, sorry, and join here. Then we have a lambda here that contains a join statement. Then we are iterating through every single snippet that we have in our code database. Now we only have 4, but remember we can have thousands here. Then we are iterating through every single result of the data.read invocation further up, and then we are adding into this node the lambda result of the currently iterated content. So basically what we are ending up with down here is a very, very interesting thing. Let me just save it first, execute it, pass in name, John Doe, email john@doe.com, and we invoke it. Now if we go to MISC, we open up our log, we will see that, hooah, we have a bunch of joins here, right? And each of these are executed in parallel, right? So join fork, let me see, it is correct. Yes, result. What we can do now, we can take the input arguments and we can pass it into every single fork we have by doing adds. And this we don't even have to do inside of the loop even. :x: at dot lambda /*/join /*/fork get nodes :x: at dot arguments /*. Then let's do another lambda to hyper :x: dot and log.info :x: minus, save it and invoke it, pass in blah 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 as name and blah@blah.com as email, and ta-da, let's now look at our log. All of a sudden now, fork, why didn't this work? It didn't entirely work. Yeah, sorry. I'm going to publish the code for this HTTP endpoint for you, such that you can have a look at it from an article where I will be publishing its code. There's going to be a link in the description of this YouTube video to that article. Let's try again. Here you see. So here we have a fork. Then we have a .result node, which we're using for the result. Then we have .arguments. Actually, we should probably even do, instead of do add, we should probably do insert dash before fork /0. Let's try one more time. This is pretty cutting edge stuff. I mean, this isn't stuff you've seen before. So, and I'm literally making it up on the fly for the record. I had a great idea, like, I mean, 20 minutes ago, and I figured I wanted to create a video about it. So here we have an arguments collection, arguments, with the arguments. Then we have a result node with some whatever node beneath it. Then we are setting the result node or adding or whatever we want to do to that specific result node according to some Lambda object that is executing, having access to the arguments. So what's happening now here is that now instead of just logging it, we can now at the bottom do eval :x at dot lambda. Ta-da! Save it. And we're now executing everything we have in our database in parallel on multiple threads. Now remember when we went to when we created our snippets, we had two snippets that were sleeping the currently executed thread for 5 seconds, this guy and this guy. Okay, now if these were executed sequentially, that would obviously take 10 seconds. 5,000 milliseconds multiplied by 2 is 10 seconds. Agreed? However, since we are executing everything on one thread, then the total execution time of this HTTP endpoint will be no more than the execution time of the snippet that spends the most time executing. And this is true if we have one snippet or if we have a billion snippets. And let's verify that by clicking F12 before we now execute our endpoint. Save it to make sure that we're executing the correct code. F5, name, John Doe, john@doe.com, invoke, 2, 3, 4, 5. And as you can see, it took 5.36 seconds. Now, the beauty of the way threading, actually you can see it here too, 5.377 milliseconds. The beauty of the way threading is implemented in Hyperlambda is that it's async to the core. So whenever the thread is waiting for I/O or sleeping, as it's doing now, the thread is actually released back to the operating system. Now, if you're creating an HTTP endpoint in a classic programming language, such as PHP or Python or Java or whatever, and you don't have async features in the programming language allowing you to implement threads asynchronously, then you know the maximum numbers of threads you can create is limited to the maximum numbers of threads you have on your underlying operating system, which is probably, I don't know, 32,000 or something, I think. With this thing, we can, in theory at the very least, we can have 1 billion threads executed, and it would still not take more time than you know, this, right? Regardless of how many snippets we insert. Now, of course, there are memory constraints when it comes to like 1 billion threads. You don't have that much memory. You need to have enough memory to be able to construct a graph object encapsulating every single snippet, right? And then, of course, it depends upon what that particular snippet does and how much memory it actually consumes, and etc., etc. So I wouldn't create billions of threads, but I mean, definitely thousands of things can easily be applied here. Now, and of course, the point being that, you know, you could integrate with Hasura, Supabase, Stripe, SendGrid, etc. And your integrations are actually dynamic because they're just database records, right? However, still all of them have access to the arguments. And here comes the kicker: return add :x plus get dash nodes :x at dot lambda slash dash asterisk asterisk dash dot result slash asterisk. Save it. Let's invoke it again. Here we have our ISTA status, 200. Here we have our JSON placeholder. Here we have our sleep 1, and here we have our sleep 2. And each of your thread can actually return stuff back to your client. Now, To be honest with you, I just came up with this idea like 25 minutes ago, and I realized, oh my God. And I just had to show it as like a beautiful thing. Now, some use cases might be, okay, you have a, GraphQL endpoint. Okay, at the same time you're invoking your GraphQL endpoint, you want to invoke Stripe to like, I don't know, pay for something, right? Okay, so you're executing this in parallel, waiting for both of them to finish. And then you get the result from both of your HTTP endpoints simultaneously. So you're basically aggregating multiple endpoints together, and you're doing it dynamically, because whatever you want to execute are just database records, and database records can be deleted. I mean, if I go now into, for instance, SQL Studio, and I do select all from snippets, and I find my code thing here, and I execute it, and then I see, okay, ID 7, delete from snippets s, where s dot snippet ID equals 7, marking my code, highlighting my code. Remember that guy? Snippets s, where s dot, why doesn't this work? It doesn't matter. Now, if I select, I just deleted one record. Remember, snippet ID is 7. If I now go back here and re-invoke my endpoint, Jane Doe this time, jane@doe.com. There is no result at the bottom here from the sleep2 invocation because that one is gone. So now instead of having 4, remember we had sleep2 previously, now we only have sleep1. So you basically have an endpoint where you can add stuff that is being executed from that endpoint dynamically on a separate thread. This is a cool thing. And this is one of those things that can only be done with Hyperlambda, of course. So anyways, there's a link in the description in this YouTube video to an article from where I will be publishing this HTTP endpoint code. Whatever snippets you want to insert into your database is up to you to decide for yourselves. So anyways, thank you for watching. Remember to like the video, subscribe, hit the bell, and share the video with your friends. Thank you for watching. Have a nice day.